Before we start with Atapon's talk, let me give you a brief overview of the project that we are undertaking. The project is called Incubating Feminist AI, and the main objective of the project is to find ways, in various ways, prototypes, pilot projects, research, in which AI could be a force for creating the kind of society where women are empowered and which gives priority or more prominent places, more equal status for women. And it's a wonderful project. And of course, I'm not a woman, but we share the same idea that AI could be a force for the creation of this kind of social inclusion. So we are looking for pilot projects and research papers and other intellectual endeavors where AI in various ways, and NLP is one such way, the topic that we are going to talk about, in which gender biases or the idea that AI has its inherent bias in its algorithm that could be disadvantage to women could be kind of spotted and identified, and ways to solve the problem identified and proposed. Atapon is here, so we can start formally. And I will introduce our main speaker today, and I apologize to him. There's a little bit of miscommunication. He thought that the talk would start at 6 o'clock, but obviously that's not the case. But he's very graciously agreed to, in a very short notice, to switch the time of the talk to our time today, which is right now. Without further ado, I would like to introduce our main speaker for today. His name is Attapon Rutherford, or Attapon Thamrong Ratanarit in Thai language. He's right now an assistant professor at the Department of Linguistics. So, our offices are close by, and we are in the same building. I am from the Department of Philosophy, belonging to the same Faculty of Arts at Chulalongkorn University in Thailand. His work, Attapon's work, is about NLP, natural language processing, the technology that enables computers to understand languages and perform language tasks like answering questions, translating texts, and reading a large amount of text. So very interesting and very, very useful for our daily lives. His current research interests are Thai core NLP infrastructure, discourse phenomena, and NLP in data science and text analytics. Okay, and he graduated from Brandeis University in computer science, as you can see here. And I hope he doesn't mind, because all these are public anyway. And he got his master's degree in computer science and neuroscience, very interesting, from Princeton, and in statistics at Stanford, and his bachelor's from Stanford in symbolic systems. So we are expecting your wonderful talk, and we have 90 minutes overall. You could spend half an hour or 20 minutes, or how much time that you would like to talk, and then we can have our discussion. So the floor is yours, Chanatapon. And once again, I'm sorry for the misunderstanding.
So that was my bad. I had it on my calendar at 6 p.m. Somehow I'm actually prefer this time. And I'm glad I'm around to give the talk. All right, so thank you everybody for coming, and thank you for the introduction. My name is Atapon Thamongratanarit, and today we'll talk about gender bias in NLP. I take it that not everybody has a strong background in deep learning and NLP. NLP is a technology for processing a large amount of text and making sense of it, or automating language tasks as we know it. Usually we talk about machine translation, sentiment analysis, text understanding in general, or like summarization, question answering. Those are some of the examples of application of natural language processing. And the reason why I also had to talk about deep learning in this talk is that it's like one of the main technologies that power most of the NLP tasks that we are doing in the present days. So before we get to gender bias in NLP, so I have to talk a little bit about deep learning and what it is. Right? Deep learning is an algorithm that learns from some data. It doesn't have to be a large amount. It learns from the data. It has very sophisticated equation of how it translates text into something that computer can understand and try to make sense of it. And a very fundamental building block of language in general, and also deep learning, is meaning representation of a word. So what do I mean by that? So when we feed something into a deep learning algorithm, we need a good representation of a word. What is a good representation of a word? Something that can tell the machine that what the meaning of the word is. Okay, so meaning linguists have tried to theorize of how we could change text into representation of meaning. One of the first attempts is to recognize, feed into the machine what's the synonyms of what, what's the antonym of what, what's the opposite word, or the words that have similar meanings, or what's the hypernym, as in like X is some sort of Y, or Y is a superset of X. So that's some quick overview of lexical semantics from the linguistics point of view. But nowadays, the model that we use to model meaning of a word is called word embedding, which I will talk about more extensively in this talk. So, what is a word embedding? It uses the idea from linear algebra, or we also call it word vectors. Word vectors is a representation which is essentially 100 numbers. We use 100 numbers, 300 numbers to represent the meaning of a word, which is kind of convenient because once things are in number form, computer can process that pretty well actually. So first step for doing anything related to language task NLP using the modern deep learning technology is that we need to have those word embeddings that represent the meaning of the words. Okay, that's a very quick overview of the current fundamental technology that powers basically all the cutting edge research in natural language processing nowadays. Okay, that was very quick. Hopefully we can move this along. And let me share the screen. I prepare a little bit of slide for this talk. All right, since okay, so gender bias in NLP. So there are 4 things that I'll address in this talk. It's a source of gender bias, danger of gender bias, observing bias, and debiasing in general. Okay, since when this is becoming an issue, right? NLP has become more relevant to the modern days, probably 10 or 20 years ago. before this, it's just like toy technology. We don't see it in everyday life as much, right? But now we see it everywhere. We see it in search bars. In any website that you go to that has search bar, it has some sort of NLP in it. Okay, so we got other things like Alexa, all the virtual assistants that we interact with nowadays. Also, and that's also NLP. Also use the modern technology. So people start to recognize the gender bias in NLP because it's more relevant to us, and it's time that we think about this kind of biases. So you could one of the first things people recognize is not gender bias, but like more racial kind of bias. So it's we first talk about this from computer vision, like an algorithm that recognizes the human face versus other objects, right? You probably saw some funny videos where an algorithm doesn't recognize African American as a person because the algorithm is biased. So that's a very clear indication that there's definitely a bias in making this technology into a product, right? So that's the beginning, and now people start thinking about other sources of bias. So we will talk about NLP today. One of the examples that I come across when I was working at LinkedIn before I moved back to Thailand and teach at Juฬาis that when I was working at LinkedIn, that's the website for posting jobs and resumes. So we found preliminarily a gender bias in search terms in general, especially in languages that are so gendered. For example, in German, you have one word for, say, teacher for male teacher, and another word for female teacher. So for most job posts, they don't require specifically that you have to be a male or female to do the job. So they will just usually they'll post a job in a male form. Okay, so when a female person or a person who uses the female version of teacher, so it's Lehrerin in German, it's Lehrer in the male version of it. So if you use the female version, then you would not get as many job posts. So if a user doesn't know that there's a bias in the system and naively search the female version out of like familiarity or for the correctness sake, then they might miss out on some opportunities. And then when the engineers discover this very obvious gender bias, we try to fix that quickly, but it's not that easy to fix quickly because it's very down in the system. So that's a personal anecdote of gender bias in NLP that I'll start with. But today I'll review some of the literature and how people have turned to raise this as an actual issue in research and in production in the industry, right? So like most of the work would be quite new because it's recently become it recently attract more attention from the research community. So you see just how they would only talk about like the newer technology, but not the older algorithms. So it's mostly deep learning. So that's the background before we get into it. So let's talk about source of gender bias, where it comes from. So there are multiple sources. So it's from the training data, from the word embedding, or from the model itself. So these three, they are obvious answer because to people who do machine learning and NLP, because these three components are very important components that we see in basically all systems, right? So training data, why is it a thing? Because for any system, usually it's a machine learning kind of system, which means we don't teach them specifically what to do, we train the model, as in we train the system from the training data. So we feed them a bunch of examples so that it learns from those examples and then try to, do intelligent things by learning from the data. So that's why training data is a very important source of it. But we'll see later in the studies that I'm going to present next that, that people have proven that is actually the case. And secondly, word embedding, which I just told you about. Word embedding, again, is a n-dimensional vectors that have the property that preserve the syntactic and the semantic characteristic of each word. So both grammar of the word and the meaning of the word all together in compact, three-dimensional vector. So 300 numbers, if you don't know what vectors are. Yeah, there are 300 numbers that can together can keep the meaning of the word. It's a pretty strange idea, but I don't think, I can talk about embedding for hours, but I just want to give just an overview of what it is. So why it becomes a source of gender bias is that now it becomes such a common resource. What do I mean by a common resource? So whenever you want to train any model and you want to make it smart, you download word embedding from somewhere. There'll be like 4 or 5 favorite versions of word embedding that people usually download from and use them off the shelf without doing anything. So if there's a bias in there, the bias will propagate into the system. So that's another resource that could be a source of gender bias. And the third one is the model itself, which is less of a problem as we will see next. So people have classified, what kind of gender bias it can be. We might expect to find in real use. So the danger of it is that it reinforces stereotypes in the downstream applications. There'll be more examples coming, and sometimes it will produce the prediction that has the gender bias in it, and then amplify the biases in the training set. Because sometimes to generate a training set, you use the model that has the bias already. So the prediction from the model will propagate right into the training set for the next model to come. So yeah, so we have to trace back to the very source of it, right? So the biases can be categorized in terms of the allocation bias, as in, as like an example I told you before. So the system will unfairly allocate resources to certain groups over others. If a female person if a person uses female terms or gender terms to search for a job and it returns fewer results, then they are less likely to get the opportunity the job opportunity that they want, right? And secondly, representation bias. It just detracts from the social identity and representation of certain groups. So yeah, they in the talk by Crawford 2017, they compile the representation bias in the context of gender or gender bias, and they try to classify them into 4 categories. So denigration, stereotyping, recognition, and underrepresentation. So if this is quite embarrassing kind of error actually. If you use machine translation and you translate, we call this stack translation. If you translate English sentence, he's a nurse, she's a doctor, this is totally fine, right? Because anyone can be a nurse, anyone can be a doctor in a perfectly unbiased world, right? So if you translate that to say Hungarian and back translate it into English, okay, then you get things like she is a nurse, he is a doctor, because Hungarian might not have a gender pronoun, okay, or the verb that they conjugate might not preserve the gender in it. So how does it solve that problem? It goes for intuitive judgment. So now machine hasn't thought intuitive judgment, so it translates back to she she is a nurse, he's a doctor. So that's a gender bias, right? Because in stereotypically, right? So that's why they have to take on the S. Stereotypically, a nurse is a female person and doctor is a male person usually. And by saying that, I'm already stereotyping, right? And also recognition, because it's actually an error. So if you have a source sentence like in English and you translate it to Hungarian, when you translate it back, it should have the exact same sentence back, but now it deviates from the correct sentence, right? So that's why we get both biases for this kind of passage, machine translation. That's essentially a classic translation error, because pronouns, not every language has different pronoun system. Some are very gendered, some it's not so gendered. So that's a classic translation problem, because the pronoun systems vary by languages. For the next task, we have caption generation task. So what does it mean? So if you have an image and you want a system to generate captions, quite straightforward, right? So if there's an image captioning model incorrectly predicts the agent to be male because there's a computer nearby. So having a computer nearby has nothing to do with the gender of a person or an agent that needs to be recognized by the machine. Since it cannot rely on other cues, they're more likely to classify that person as a male, because computers usually associated with male. Then it already feels weird saying that out loud, actually. So that's also like the same problem, right? So it's stereotyping people that are close to computers, most likely are stereotypically male. And that's also a recognition error, because the machine makes actually an honest error, because it should not be. It makes a wrong prediction, right? Speech recognition, so it can be underrepresentation kind of problem too. So in Tapman 2017, they found that the speech detection system worked better with male voices than female voices. Like very similar to the example that I gave earlier about an algorithm that would detect a human versus non-human. So yeah, in this study they found that this kind of system works better for male voices. So that's an underrepresentation problem, because usually it depends on the data that you feed in. And again, sentiment analysis ranks sentences containing female noun phrases to be indicative of anger more often than sentences containing more male noun phrases. That's another example. And a language model, which you'll see more actually in this talk. A language model is a model that gives you a score of how representative that sentence is of a language. So it gives a probability of seeing that sentence in a language. All right, language model usually talk about it for 2 weeks for somebody to understand, but that's the gist of it. So they found that the sentence "he's doctor" has a higher probability than "she is a doctor." Why? Because they see that more in the data. So the bias is actually in the data, but it shows up in the output of it. All right, so these are some of the examples that people have found to be problematic in terms of gender biases. So how do we know? What are the methodology of doing that? So we do something very close to a classic psychological test called implicit association test. So in IAT, implicit association test, participants are asked to make some sort of association task, and when So you can measure the association between concepts and like evaluation or stereotypes. So if the brain thinks that they go together, say black and athletic, if they think that goes well together, you see lower reaction time because that means the brain has to process that less when they need to make that pairing. But again, I'm not going through the detailed IAT, but the gist of it is that it measures the association for each person that does the test. So the main idea, I already said that, right? So yeah, you can test each person's stereotype. That I think implicit association test, if you Google, you can do it for all sorts of biases that you could think of, like gender, racial, for each occupation, even they have like a very long standing study. I think it's done at Harvard. That's a classic psychology actually. So we do something like quite similar, but not with humans. So we use word embedding to measure the association between each concept with male or female, but you can do it for most concepts as well. So in this study, they take the word embeddings that are male related, like male, men, boys, man, for example, but they have a set of words that signify a male, okay? And they have another set such as like female, woman, women, girl, girls. Those are all the female words, rightfully so, right? And then you compute the similarity of the male words with each, say, occupations or names, okay? So what they found is that the association of say male and female are almost perfectly correlated with the actual percentage of workers in each occupation. For the graph on the left, the x-axis is the percentage of workers that are in that occupation. So each dot is each occupation that they test with, and on the y-axis they test the association using the word embedding, say like plumbers, doctors, construction workers, or all and the occupation that they have the data for. So you can see that the association has a very strong correlation of 0.9. It's very rare that you can see that kind of correlation in most data sets. Actually, if you have some statistics background, it's very hard to find an actual data set that has that strong association. But we indeed have that kind of strong association. So what it means is that the word embeddings, so like the thing that represent the meaning and also the grammar of each word, actually absorbs, actually encapsulates, actually registers the percentage of workers in that occupation in each gender. So it's already been absorbed in that. So once you take that word embedding and put it in any downstream model, that kind of bias is going to propagate. So they use this test to pinpoint that this is actually a problem, and it's actually in the word embeddings already before we even do any kind of modeling. Okay, so on the right, they do similar things, but they do it with names because it's pretty clear, right? It's very hard to find a male person whose name say like Susan or Mary or Linda. There are names that are stereotypically male and female, although technically there should not be anything that stops you from for a male person to name themselves say Cherry. That's nothing to stop them, right? But that's what the data shows that stereotypical names for male and females do exist. And the word embedding, we also have the embedding for each individual name also absorbs that. Okay. All right. So we have established that we will look at these embeddings, because these embeddings are we have proven that there are gender biases in them. So once we can identify the gender bias in it, like say each occupation, because it should be 50-50, right? It should not be strongly associated with one gender more than the other. If we want an NLP system that has no such bias, so that leads to a whole new line of research. Actually, started probably 10 years ago. It's quite a new issue to do de-biasing. So people come up with all sorts of algorithms that will de-bias the word embeddings in particular. So that's the first line of attack for them. So hard de-biasing, there are two types: hard de-biasing and soft de-biasing. So there's a neutralizing kind, so it ensures that gender neutral words at zero are zero in the gender subspace when we try to project it onto the two other occupations. It should be quite neutral, and it should equalize set of words outside of subspace and enforce the property that any neutral word is equidistant to everything. Okay, that's a hard de-biasing, which we won't do as much, but most likely we'll do soft de-biasing. So we do any kind of de-biasing we want, but at the end of the day, though, we need to preserve original properties, because word embeddings are very important. It's a building block for most models. So if in this process you de-bias it and it messes up anything, so then there's no point in using these word embeddings anymore. So that's the challenge of de-biasing line of research. So in this study, like for example, they have to look at hard bias and de-bias. So we should have this kind of results, right? So we on each column we have RG, which is the training set of sorts, which I won't talk about. We have word similarity, WS, and analogy test. Those are the tests that will test whether the word embeddings that we are using are effective or not. Okay, so it turns out that we could successfully run the de-biasing algorithm and make no significant changes one way or the other onto the benchmark data set that we use to assess the performance or the accuracy of the word embedding. So that's good news, and that's the kind of algorithm that we want. Okay, so what about the performance, right? If you look at it on the more on the performance side, sorry, I won't get into much of the algorithm, but it's some metric, which I don't think that's it would make much sense if you don't if you haven't seen the equation for word embedding. So sorry, I skip those for now. So, but if you have more questions, I could send you the references. Okay, so another idea is to do this is to if you notice that there are recognition problems. So for male and female people who use the system, they should be able to expect the same kind of performance, the same kind of accuracy, right? Like when back to the example that I gave for from LinkedIn, if you use the female version of the job versus the female version of the job, you should get the exact same performance. Or in speech recognition, if you use if a male user with a male voice uses the system, you should have the same accuracy as a female counterpart. Okay, so that's another bias that we will try to measure. So yeah, so the model prediction should not be influenced by the gender or the dimensions or the context that are so gendered. So for example, if you say perform sentiment analysis, you want to know whether a sentence is reflects positive or negative attitude, you should get the same label regardless. Okay. So for example, he went to the park versus she went to the park. For any label, for any classifier, for any system that you use, it should produce exact same output because there's no reason why it should not. Okay, except when you want to translate this. Maybe you want to use the, say like Korean male pronoun to be translation for he, and the female one for translation for she. And that's fair, but for a classification task when you try to put a label on a sentence or on a piece of text, it should produce exact same output. So within this slide, they come up with gender bias evaluation test set, GBET, which become actually a very important benchmark for this line of research. So they got a bunch of data sets that they collect. They call it Wiener gender schema, which come from Winograd schema. So they changed Wiener to Wiener gender, and that's I guess clever. So the task is co-reference resolution. So you could see if it performed differently or not when they try to resolve co-reference. What is co-reference resolution? Real quick, it's a very important task in NLP. So it tries to resolve nouns that are, that we want to know what it refers to. One important case of it is pronoun resolution. He, she, it, and they, and we. We want to resolve what they refer to in the text. Okay. So sometimes it's not so clear, what it should refers to. So we built a very complicated deep learning algorithm actually to perform co-reference resolution. It's a very challenging task to begin with. So if you want to avoid gender biases as well, it would be even harder. But it's still worth doing because you make the system more accurate. Okay. So they collect a few evaluation tests and and make it like a standard benchmark for evaluating whether an algorithm has bias or not. Okay. And they also have a sentiment analysis task. So you could probe it with emotion. So on the third axis, on the third column, sorry, they have probing concept. What does that mean, right? We could try to basically probe it, like trick the system, like whether he will be more likely to be resolved to a doctor or not, when it's kind of ambiguous from the sentence, or she is more likely to be resolved to a nurse, for example. But I'll have more example next slide. And for names as well, if there are, you can also like probe it with names, or you can probe it with emotion, because there are some stereotypical emotions that are stereotypically associated with one gender or the other. Okay. All right. We know gender schema, and it's actually like very interesting. So it comes from like Winograd schema, which kind of tests very high level understanding of language. In Winograd schema, we think that if a system can solve Winograd schema, the system actually understands language and understand the meaning of language. Okay. So let's look at some examples of Wiener gender schema. So they twist that and make it more gendered. So let's look at 1A. So that's occupation and participant, right? So paramedic perform CPR to resuscitate somebody when they pass out, stop breathing. On passenger, even though he, she, they know it was too late, right? So in this schema, though, it it doesn't matter whether it's he, she, or they, or even he, she, or they there. It should all refer to the paramedic, right? Because the passengers already passed out on the floor. If they cannot possibly know, it's too late. So renal grass schema would be something like this, where if you know the meaning of the sentence, you should know exactly that that pronoun should be resolved to the paramedic and not the passenger. But in renal gender, they twist it a little bit and test it on he, she, and they, on all gender and non-gender pronouns. Okay. And then on the 2A, again, paramedic perform CPR on the passenger, even though he, she, they was already dead. Again, it's very clear for humans anyway. For computers, it's still quite difficult that the pronoun should be resolved to the passenger, right? So yeah, so in these cases, for 1B, they make it a little bit more vague, right? By replacing the passenger with someone, and same for 2B. It's the same version of 2A. It's very similar to 2A, but they changed one word. Okay, so what we should see is that he, she, and they in English, they can also be used instead of he and she when you don't know the gender of the person, because paramedic can be anybody, right? If you haven't seen them or know exactly what gender they identify with or what pronoun they want to use, then you use they. It's pretty safe. Okay, so they become a singular, gender neutral pronoun, which some native speakers reject, some accept that, but I think become more acceptable nowadays to use they. It's still followed by are, right? But they can also refer to a singular non-gendered person. Okay. So that's a renal gender schema. So if we test co-reference resolution system, then we could see whether it's biased or not. So in this study, they test three types. That's a rule-based kind. So you write up the rules on how to resolve it. Usually you go back to the previous sentence and see if the subject actually agrees with the pronoun. For example, paramedic, that's a candidate for resolving the pronouns, and it agrees with he and she, because paramedic is singular and it can be he, it can be she, but we can code that indirectly that it can be the case. Okay, and for statistical, we will learn from the data whether it should be resolved to those noun phrases, and then we use neural network, which a deep learning technology that we actually use nowadays to perform co-reference resolution. Okay, so from these plots, it actually turns out that the system is actually more biased toward one gender over the other. So yeah, it's not super surprising, right? Because we haven't done anything to de-bias it yet. So most likely we will if you use embeddings that are already biased, very likely that you will get the biased result. Okay, so those are some attempts, right? Because if we have a way to know and also a way to measure whether we are biased or not, then it's very easy to make progress. And that's the logic of NLP research. We have the standard benchmark data set. We have the metric that measures what we want. In this case, the metric that measures gender biases. So we have these sets. So we can come up with more algorithms, and we can test them out whether we are successful in eliminating the bias or not, or de-bias the system or not. So there are two kinds. The second kind we already talked about, like briefly. So we can debias in the word embeddings themselves after you already train the word embeddings. But you can also debias on the training corpora as well. As I said before, since most modern systems that we use in NLP now are machine learning, so it needs data, and most likely you will need the word embeddings as well. So we will attack these two sources first, but let's look at how we can debias the training corpora so that it doesn't propagate the generative biases onto the downstream task. Okay, so we could use this technique called data augmentation. Data augmentation means we generate more data. So usually in the training data, that means the data that we use to make the model smart, the data that the model would ingest or learn from to make itself smarter. That's the mantra of machine learning. So we try to augment it. What does it mean? We try to fudge with it, modify it. Usually we try not to do that unless we have a very good reason for it. And this is one of the good reasons for it. So we try to augment it. So we try to make the data more gender balanced. So how you do that? They try that out with GAP, gap corpus. So they have the co-reference label pair, that means ambiguous pronoun and antecedent name, right? Sample from Wikipedia and used for co-reference resolution. So for example, I voted for Nader because he was most aligned with my values. So he, if you have more of these data and you see the name Nader, Nader, and it got resolved to he more often, so the model is going to learn that. It's very hard to stop the model from doing that actually. So because it uses statistics, right? What they see the most becomes knowledge. So if it sees that he is associated with the name Nader more often, it's going to have that bias, and there's no way around it. And the way around it, so I was wrong, there's some way around it. That is, you generate another set of this and put it and add it to it and change he to she and change it to the training set. Okay, because Nader is actually kind of a rare name. If you ask an American or a British person, they would not know exactly what if a Nader should be a male or female, right? So they debias it by when they see that a name is connected to a pronoun, add another instance so that it balances itself out. Okay, but for the red one, it doesn't matter, like she and mine and I, right? So Birch. So yeah. So the problem. So another example for debiasing it is to change something in the model. So the problem is that we want to observe and measure the bias and also and try to mitigate this problem in BERT. What is BERT? Like you ask. BERT. Usually, BERT, I will talk about it, for like 3 hours. So for most students to actually understand briefly what it is. What BERT is for now, it's just a very, very good system that actually revolutionized the field of NLP 5 years ago. It got revolutionized twice since I started doing NLP. Lucky for me, I guess. So you can just think about BERT as like the best model that we have so far for NLP. It's used for most things nowadays. So since it's such an important model, so we want to make sure that it's actually good and potentially bias-free. So first we have to probe it and try to observe the bias in it and then mitigate it later. So BERT usually is trained on billions billions of words of data. Okay, billions of words of data is large amount, more than we can imagine that a human brain could imagine, how much that is. We could imagine like 500 words, right? Which is like, a few pages of essays, that's 500 words, right? But when you talk about like billions, we could not really imagine how much it is, but it's a lot. Just think more than we could possibly read in one lifetime. Okay, so usually BERT is trained on a large amount of data. So since it's trained on the data, we can also debias it by changing the data as well. So to do that, you could also tuning using mass data. So how do they do that for this? So if you have a task like this, right? When you have a target, let's say like sun is a very male word. Okay, so usually when you train BERT, you try to make the model guess what word is in the mask. So you hide it and try to make the model guess what it is, guess what that word is, right? There can be many, right? There can be anything in there, like my son, my daughter, my wife, my husband, there's a lot of words that can go into there. But you force BERT to learn from the context what word is in that position, and that's what makes BERT smart, right? It's have a lot of exercises in guessing words that are missing, like closed tests that we did in entrance exam and whatnot, right? So yeah, so it's just a bunch of closed tests, and if you don't do anything to it, of course, it will try to absorb the statistics in the language, in the data. So most likely, it will guess the word that's in the mask to be some male words. And that's not what we want, right? That means that the system encodes this bias somewhere. So we could also map the attribute. So like, if you have the structure, my blank is a blah, 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 you could map all of that, right? So most likely, if you do that using just map the attribute, it will try to learn something that's like associated with sun, which is male word, right? So if you map both target and attribute, then you have a chance of debiasing it. So I think this is like observe again and again. So if you map the place where a gender word could go to, it will put in some stereotypical words. Okay, so for the first step, when you try to debias BERT, you get a sentence with both target and attribute. So it is in this structure. He's a kindergarten teacher, right? So you have target he, and you have kindergarten teacher, which is the attribute. So you map target word, and then you try to find the probability of that being he. All right, and you could also map both target and attribute words, and in compound map each component separately. So you have mask is a mask. So and then you can obtain the probability of target word when the attribute is masked, and then you can compute the association. So I'm gonna skip on these. So you could see like the biases that I described earlier. It will put in he when they see the attributes that are stereotypically male. So to do that, how do you do that? So there's a bunch of ways that we can again augment the data, which means we'll modify the data in some way that will eliminate the gender biases. So you could use the name base counterfactual data. So you can substitute some of the names so that it balances out, right? So like you could use the name that are, if you see the name that are male, you can substitute it to the name that are female, and that's usually quite easy to do because you have to do this automatically for a large amount of text. So, so for the gender of birth denoting person, you can swap in place in order to counterbalance the bias. So you get more data. So you get a copy of it that's of opposite gender, and you also replace the first name. Okay, so there are a bunch of things you can do. These are some obvious things, right? These are some preliminary work. Okay, so here's the results. So on the top, right? We on the x-axis we have each occupation that are usually quite stereotypical of one gender or the other, and so we have carpenter, and like you can label that yourself, whether one is more biased toward male or female, right? Like roofer, plumber, steel worker. Usually they are typically very manly occupations. So if you look at the result from the figure, the top one, you can see that it's very biased, right? So it's more so it favor one gender over the other when you look at the association. Okay, so that's not good. So you see the biases, but after de-biases by modifying the training corpora in the way that I just described before, replacing the names and duplicate the data, replacing the names, duplicate the data, changing the pronouns. That's actually quite effective because so you can see that the association actually go hand in hand now, right? So before you see that it's negative for female and positive for male. So it go in different directions, positive or negative. But now you can see either both negative or both positive in almost equal amounts. So that's actually a success. So we could actually debias the model itself because you change the data and then the model behaves differently. So when you look at statistically, they don't say stereotypically. They actually look at the number of people, the number of people that hold each profession and count, the percentage of each. And these are statistically female professions, housekeeper, receptionist, secretary, and so on. So you can see that before you debias it, you see that the association goes in a very different direction, right? So for say housekeeper, the association is more toward female and negatively toward male. So that indicates the gender bias. But after fine tuning, as in fine tune with the corpora that we modify in a way that I described before, the gender biases kind of go away. So that's good news. So just for one more example, I think we still have a little bit of time. For machine translation, that gender bias is not the only problem in machine translation. You can see many other translation error, right? Because it's still quite not so mature for real application for machine translation. So we could do something that like gender tagging, can tag it so that when you translate, it behaves in a gender unbiased kind of way. So, but we think that like masking, that's in masking it might decrease the accuracy for machine translation. What we found though is that MT as a machine translation mostly predicts the source to be male because training sets are dominated by male source data. So when it doesn't know what gender it should be, it would just try to guess something male related. Because there's more of those. There are more of those in the data. So we just hope that gender tagging would mitigate this by adding a tag indicating gender of the source of the data point, and then increase the gender awareness for the model. So let's expand more on this idea of gender tagging onto the data. I think I'll show the data in the coming slide. So yeah, grammatical gender, huge problem because it's almost impossible because sometimes you just don't know. In one language, it might not so gendered. It might not be so clear what gender it is. So when you translate it, it's most likely to be a he. It's most likely to be some male-related thing. So that's a problem of underrepresentation in the data. So to do that, you try to tag it as in like a non-word. You kind of tag it into the data so that it will learn the association. And we try that with English to Spanish and English to German translation to see what happens. So for example, if you have an English source, the trainer finishes work. Trainer in English is not gendered, but in German it's Trainer or Trainer because they have the in suffix to make a word that ends with an er that is male into a female version. So you can see that the article there and D, there is for male, D is for female, and seine, it means his, and ihre, it means her. Okay, so that's kind of consistent for the English source, right? But for when you translate like this, the trainer finished their work, there and it's not. So there, as I said before, there's gender neutral because if you don't know whether your trainer might be like your personal trainer, right? What gender they are, then there is a very thing. You know, don't in English to be nice, to be politically correct, or to be nice. Let's say to be nice. If you don't know it, don't guess the gender because if it's wrong, it can be very offensive, and that's not a very nice thing to do. So sometimes we use there, right? So so for his and her, it's quite easy, right? Because then if it's his work, then you know that trainer should be male or identify himself as male. When it's there, we should change it to something like this, as in definite pronoun, and trainer will think later whether we should change it to a word ending the suffix that make it a female or not. And then PRP, that's the possessive adjective, right? Which we don't know where we should put in either. So a good system that outputs this should give you an output like this, right? That are so gender neutral in German. Okay. So yeah, that's the idea of like tagging the scheme. So that's so you change this directly, right? So so for this, we could do something like when you have to really enforce it. So we could have this version of B1 where when they test whether if you tag it directly, that trainer male, because it's very clear from the context. So that is more reinforced when you see this in other contexts, it might then it can translate it correctly. Or if you have a mixed thing like this, like the trainer and the choreographer finish the work, you can tag it whether one is neutral, one is female, and you could do something like this as well. The trainer tag is a female, and the choreographer is a neutral. So when you translate it, trainer, the tag of female can be directly translated to trainerhund, which is the female version of trainer. And for the choreographer, I think that there are two versions that change the ending for choreographer in German. I don't know German that well to know what the words are for German. And similarly for Spanish, if you know Spanish, you probably know what it's talking about. But yeah, but you can see that it takes the word takes different ending for the male version and for the female version. So yes, so it turns out when you augment the data with tags that we do it in V3 and V4. So this version, the accuracy actually go up, which is nice. So it's not only to debias the model just for the sake of gender inequality, equality and whatnot, right? But it actually makes the output better. So it's not a social issue. It's also a technical issue that we need to recognize and then that we need to solve to make the system more accurate. Get this part. All right. Okay, I think we've that's the last sample I have. So yeah. So these are, to recap what I said before, I basically just review some of the newer works that we see in NLP research. Gender bias has been recognized as another research topic that more people have been looking at and try to address. And the biases are usually come from the data that we use to train any kind of model we want. So we can see that one way to address that is to augment the data. First, try to recognize where the biases are, and then you try to counterbalance it by adding more data to it, which is called data augmentation. So, and also another way, which we have seen with word embedding, is that they use the metric so that the word embedding for the female and the male version become more similar, and while preserving all of the characteristics of the word embedding that we see in the bias version. So we want to keep the accuracy intact, if not improving as well. So all in all, you can see that these are another, not just the source of bias, it's also the source of error. So while solving this, we not only make the society a little bit nicer, but we also make the system more accurate and making progress in NLP advances. So that's all I have today.
Yeah, thanks a lot, Attapon, for your very insightful talk. We have a few minutes for questions and discussions. I hope you don't mind that we have some discussion. So the floor is open. You can either type in the chat box or turn on your microphone. While we are waiting for the question from the audience, I have a little bit of questions for you. I don't know if you have started thinking of the same kind of thing for Thai language, and I kind of think that there could be some biases inherent in Thai language itself, especially when we talk about pronouns. Of course, we all know Thai pronouns, and the fact that gender is kind of embedded in a hierarchical use of language, especially pronouns, big topic. I don't know if that issue has kind of crept up into thinking or research in NLP focusing on Thai language. An example that came to my mind is the pronoun nu that is used by females. It indicates kind of inferiority and the idea that because males do not use this word, it's typically female use, and also the ending, polite endings, klap or ka. I don't know if you have anything to share with us about all this.
Well, Thai NLP, that's a whole different issue, right? We have a more basic issue.
Ideas, yeah.
Right. yes, I mean, actually, there's some research in our own linguistics department. Ajahn Pawadi, actually an expert in language and gender in general, and they actually look at how people actually choose the pronouns for themselves when their gender is not so binary. So that's an interesting line of work, which I would like first to try to again like the line of research that I just discussed. We need to observe it first in the data that we actually can see it, and we can actually pinpoint it down that it actually affects the system in a measurable way. So I think that'll be a wonderful line of research to start with. But I think for NLP, we have more other pressing issues, like for example, like if you want to recognize it in the coreference resolution kind of problem, which is very relevant, right? Because you try to see whether that pronoun is associated with something more stereotypically male or female or not. We don't have that data set, so it becomes quite difficult. But for the word embedding kind of work, I never tried it myself, but I'm very sure that we're going to see a very similar result, if not worse, than the English version, because the language data that we use to train these embeddings, they absorb what happened in the society. So like it's not very unimaginable that there are biases in the text, in the content of the text that we use to train the data, to train the model. So it's not unimaginable.
Thanks. Another question from Jert, Ajahn Jert from Mahidol. What if bias happen over time when data are more frequent later on in the system? Or Jert might want to explain your question out loud, because he is sending me a DM. How shall you de-bias unforeseen data?
You bias unforeseen data.
Yeah.
Okay, I think should I try to answer?
Yeah, please.
Okay. Yes. Languages do change over time, and that's a challenge in just like NLP and machine learning in general, because in general you see that your accuracy kind of degrades over time, and why is that? Because language changes over time. So if you learn from the old and stale data, it's very likely that it will it just do worse over time. Same with this, right? So like when you try to chase one problem, another problem, another source comes up, you have to chase that down as well. So yeah, the answer is not very satisfying, because then you have to see what the next problem is and try to solve that more individually. But we just hope that if it's something that's more systematic and it's it can be generalized into the more unforeseen data, then we should not have that much of a problem. But yeah, there's no guarantee that it will actually generalizes to other sorts of problems. Hope that answers the question.
Ajahn said thank you.
Oh, thank you.
Any further questions? Why don't we have a few minutes left before 5:30? And once again, I am sorry for kind of miscommunicating with you.
No, it's I think it's my fault. I'm pretty sure it's my fault. I'm sorry.
But thanks so much for coming in such a short time. Yes, Caitlin asked me to reintroduce you. Attapon is assistant professor in the department at the Department of Linguistics at my faculty, the Faculty of Arts here at Chulalongkorn University. He and you can add to that, of course. He has a PhD in computer science from Brandeis University in the US. And I just learned that you have 3 master's degrees in what areas I don't remember, but one is from Princeton, the other is from Stanford. The third one is from, I think, from Brandeis, right?
That's right. Yes.
And you got your and he got his bachelor's degree in symbolic systems from Stanford, and he has done a lot of research on natural language processing in general. And I'm as my question showed, I'm trying to kind of invite him to come to Thai language and its intricacies, and how computer could do that. So yeah, and Kelly has made some comments publicly to everybody.
Yeah,
so,
can I?
Yeah, please, Kathleen, please jump in.
I'm going to reveal myself here, which I was not. I thank you so much. I don't know. Yeah, hi. Thank you so much,
Hi.
Suraj, for inviting and allowing your colleagues from Women at the Table and the FAIR network of which you are a part, and the A+ Alliance to attend us. So amazing presentation and putting together, because we all day long, all we do is deal with bias in gender, and we have NLP friends, and we have image friends, and it's just the way that you've put this all together in a presentation is beyond impressive, as are your academic credentials, which I
Thank you.
won't even go into. So my question to you is, we've started with this thing called the AI and Equality Toolbox. We've started with one simple, where we're training, sort of master's level students in data science, trying to help them understand the linkages between human rights and code. It's a very kind of simple thing. We can share you all with it. We have one Jupyter notebook that just deals with an old German data set that has no protected characteristics to play with and to see how you could help do credit loans at a slightly more equal basis. We're realizing now that over time, we want to do a series of notebooks with different data sets. So for example, Smith College has just now given us a whole class that will do a predictive policing notebook, where we'll retake the COMPAS system and we'll try and see, could we make it fair or not? What was the problem? Was it, whatever, you can understand what the questions would be there. I'm thinking that the work you've just presented in NLP, I've never seen anyone amalgamate it so that you could try to degender a data set. So first of all, that's my first question. Is that work already been done? I have something else to say about the use of they, which I think might solve everybody's problems, but that's my second question.
So usually though, like most paper in NLP, they will have code associated with it. So they'll come with a link to the code. Usually it will have some notebook that you can try out as well. But I have not personally go through each paper and try out their notebook. But yeah, I haven't heard of anybody that will compile all these things to want to demonstrate how the system show certain biases and how they detect these, right? But they report it in the paper. But I'm sure if somebody dig through the code, dig through that code base, there'll be something of that sort, because that's it's the research culture for NLP at the moment.
Okay. My other question is, all of a sudden I'm thinking, so we're a feminist system change organization, which is the larger part of our work. And all of a sudden I'm looking at this and thinking, if we just went to the use of they, which has all sorts of political connotations, but I'm just thinking on a pure technical level, it might solve a lot of problems. And have you been thinking about that at all?
It's from linguistics point of view, though, English is just a language, right? So it seems like you solved it, but probably just for
Not, okay.
that, right? And there's other ways to indicate genders, as I said in talk, names. People need to have names, right? And some names are more associated with males than others, right? So that's already in there. We cannot go without names, right? So it's not quite, but it is something. But that's a big change, though, to like, hey, we're not gonna use he and she anymore. We're just gonna use they for all cases.
Right.
It's a big
So
social change. It also doesn't quite solve the whole problem yet, and it's also just one language.
Right. So also, I'm sorry to ask too many questions, Suraj. One last one. So we're not, I'm sure there are many papers, but we are unaware of them being English just being one language. Are there in Mandarin? Is this a big problem? And are there people doing like massive research in NLP? Is this like another big thing happening there?
Yes. Yes.
Okay.
Yeah.
And are they coming up with the same solutions that you've just described? Are they basically the same?
So for language research, we kind of pick one language as a thing to study. So we just hope that if you use the same method for other languages, it will just work kind of the same way. So it's like English is more like a prototypical language for us to work with
for the internet. Yeah,
can understand it.
Yeah,
but there are some more language specific issues as well. As say for German, right? They have the word for trainer, a male trainer, and a word for female trainer, or like a male teacher, female teacher. There's two versions of that. So that's a more language specific issue, right? That you have to deal with more specifically.
Yeah. Yeah. For me, what's interesting to watch over the next 5 or 10 years is to see whether certainly Indo-European languages, so like all the European languages that are much more he, she gendered than English, whether they'll wind up going towards a default word to solve machine learning. In other words, the need to solve the technical problem will actually change the language in a weird way, because I'm curious to see how that will be an evolution. But
it won't come easy. Social changes don't come easy, right? And also there are more problems. Like some languages won't have the day. For French, you have they have the male days and then the female days, right? Are we gonna throw those away and replace that with another, the way we deal with like Z and Zer, right? Inventing a new pronoun, that's when you invent this kind of change, it's usually met with like quite a bit of resistance. So it will take some more time for sure. And
I think my comment to myself basically is it's interesting that it's a technical problem, and we've been looking at it as a mostly a political problem, but actually that it in a weird way that the technical
intertwined for sure.
Yeah. Thank you for that.
Yep.
Inspiring me to thinking something new. Okay, thanks.
Yeah, for joining the discussion. I think we have time only for one last question, if there is any from the audience. We have quite a few. We have 21 right now. Used to be 25, but some naturally dropped out. Well, if there is any, Kathleen, would you like to introduce the project just for a few minutes and the call? Is it appropriate or
well, we just say quickly that the A+ Alliance is a group of academics, technologists, activists that got together initially to try and make sure that that the new systems of the future don't embed the biases of the past, right? So what we're, as we all know on this call, who are working on these issues, it's not, because it didn't seem enough to us to just work very hard to make sure everything stays exactly at the same level of bias. So we worked towards a new idea of maybe we could be proactive and correct for bias as well in the systems that we're working. And this notion of feminist AI that we work with is the AI that's actually consciously created to correct for historic inequities in systems. So that we're actually looking for pro-social good needed by communities, as opposed to, a crypto, new cryptocurrency or a pizza app or whatever, all the other great technological things that are happening. Our definition of feminist AI is so you can call it also humanist AI if that makes you feel more comfortable, but we feel that it actually kind of gets to the heart of the problem. It's about being inclusive. It's certainly, we have a male, female part, everyone is partners to create things for communities. So we've been very lucky that the IDRC, which is the research arm of the Canadian government, has been rather visionary and just read an initial paper we wrote and has been funding us, and now funds the FAIR Network, which is the Feminist AI Research Network, of which Chulalongkorn Karn and Professor Hamladaram is a part. He leads the Asia Hub. We have a MENA Hub led by Jordan Open Source Association, which is a long-standing activist open source group, very well known in the Middle East, North Africa region. And in Latin America, Caribbean, we have two partners. One is Tech Costa Rica, who's Women at the Table's partner running the whole alliance, but also Tech Monterrey, very well known, if you're a Latin American person, is they're kind of the MIT of the South. And we're very, very deeply embedded in Latin America for a variety of reasons. We also have a sister network that's really exciting, that we're just, it's just in formation and we're just learning about, but that's run by a consortium of IPAR, which is in Senegal, that works with rural farmers, WeBird AI, which is a group that has left Google AI and decided to do pro-social AI. So they're kind of like a kick-ass bunch of ex-Googlers in Uganda. And we have another think tank based in Nigeria. So it's an interesting amalgam in Africa. And we work together, and we invite all of you to be part of the Asia Network. Anyone who's part of the Asia Network can be part of our global network. And in closing, I'll say we had our first meeting of the global network this last Tuesday, where we had Emily Denton from Google AI present the work on benchmarking data sets that was just presented at NeuroIPS. And we had Rajetshi Savala, who is now working for DARE, which is Timnit Gebru's new group, presenting her work, their work actually, they both did that paper, also presented at NeuroIPS on spatial apartheid and how those two things kind of work together. So we have a research agenda. We're trying to be as multidisciplinary as possible, so thoughtful, computer scientists and social scientists together in collaboration. We are looking at predictive analytics this semester. We're talking about semesters, but it's not this quarter. Predictive analytics, we're going to be looking at what the smallest viable data set is. We are looking at feminist AI from an anthropological point of view, which my colleague Ingrid Brudvig, based in Cape Town, will lead, who's a digital anthropologist. And finally, we have an open call that we're just about to open for principal investigators based in the Global South, in Asia, Southeast Asia, and MENA to propose new models which might include having to invent a new data set in order for the model to work. But it's that modality is call for papers. We have the papers. Then 1/3 of those will go to prototype, and then 1/3 of those will go to pilot. So we're really looking to do applied research. And we invite you all to go with us on the journey. Sorry.
Yeah. Thanks a lot, Caitlin, and I'm glad to be a part of this wonderful project. So it's a few minutes over time, and on behalf of the FAIR Network and the Center for Science, Technology and Society, I would like to thank you so much, Attapon, for sharing with us your research and your thoughts about all this. So we will keep in touch, and I or my assistant will contact you about all this afterwards. So I would like to end the meeting. However, I would like to invite Caitlin and Prodran to stay on for our kind of talk. So thank you very much.
Thank you, and sorry again for the
No, it's all right.
It was my fault for booking myself on the wrong time. Yeah, thank you for inviting
it's all
me.
right. No problem.
Well, thank you. Wow,
Thanks so
you were
much.
great.
Thanks
Really
so much.
impressive.